I'll look at some limit issues from the homework problems. This is number 29, and what you find out is if you try L'Hopital on this, it's immune. You do L'Hopital twice and you get the same function back, so you think you're stuck. But just use our kind of common sense about what happens when x gets bigger and bigger and bigger and which term dominates. And in the bottom, of course, x squared is going to dominate over 1, so this thing becomes x over the square root of x squared, so x over x, so 1. That's the easiest way to do it. It's a little reckless. The official way to do it is to rewrite it like this, and this would only be like an A question or a bonus. I don't think you ever actually have to do this, but basically you factor out. You make everything over x squared here, and you factor that out. As it goes through the square root sign, it becomes x. Then underneath here, you have x squared over x squared plus 1 over x squared. This makes a 1, that makes a 1, and the whole thing equals this. 1 over the square root of 1 plus 1 over x squared. And that's as x gets bigger and bigger and bigger. And in the books for the mathematicians, they say, okay, you're allowed to say this approaches 0, so the whole limit equals 1. That's the official way to do it, but my way here is just as good for me. That's perfectly fine. All right, the next limit is this one. And if you look at this and you say, oh, I'll just do L'Hopital, you're wrong. Because it's not 0 over 0, it's not infinity over infinity. The top, as x gets bigger and bigger and bigger, the top is going like this. There are multiple ways to do this problem. The first one is just to kind of use common sense and say the top is bounded, is trapped from -1 to 1. -1 to 1. That's as big as cosine can get, negative or positive. But the bottom is increasing. So you have something that's bounded over something that's increasing. And that tells you that this limit has to equal 0. It's got to be shrinking. The second way to do this limit is to look at the graph. And if you just think about what the graph would be like, we actually have had this graph on tests and talked about it in classes, it looks like this. Keeps shrinking and shrinking and shrinking, so you see that the limit, or the y value, is getting closer and closer and closer, being trapped near y equals 0, so again, this limit equals 0. Right? And then the final way to look at this is kind of the official way. It's called the squeeze theorem. And what you say is the ear limit, cosine x over x, is always less than, no matter what x is, it's always less than or equal to 1 over x. And it's always greater than or equal to -1 over x. And as x gets bigger and bigger and bigger, both of these things go to 0. So your limit gets trapped between two things that both approach 0. I really should write it that way. Approach 0. Therefore, the squeeze theorem says your limit has to equal 0. All right? And then our last issue is what to do with this sort of thing. So take a look at that. Limit as x gets bigger and bigger and bigger of x to the 5th over e to the cube root of x. Yikes. There are problems like this on the homework, and this is a L'Hopital, right? It's infinity over infinity. Infinity over infinity, getting bigger and bigger without bound. So you might think you'll try L'Hopital, and there were ones on the homework like that, and you did L'Hopital a few times, and you either got to the answer or you could see where it was going. But this could be a real mess if you use L'Hopital. So in another video, I'll show you what are called growth rates. It's a shortcut, but I want that to be a separate issue. For this one, for this limit, I'll show you the accepted procedure, and that's to do a change of variables. And watch what happens when you do a change of variables. You let u equal that, the cube root of x. That means that right away, x equals u cubed. And what's important, something you never have to do when you do integrals, indefinite integrals, when you're just finding an antiderivative, you don't have to worry about this when you do a u substitution or a change of variables. But you do have to worry about when you do a definite integral, and that's the limit here. So as x gets bigger and bigger and bigger, since u equals the cube root of x, u also gets bigger and bigger and bigger. So if you do that, you're ready to change all the variables. And you get that this limit here equals the limit. As x gets bigger and bigger, u gets bigger and bigger, so we can write that. u arrow infinity, u increases without bound. X to the fifth, well, since x is u cubed, this is u to the 15th, divided by e to the, well, that's why we did it in the first place, because cube root of x is u, e to the u. Okay. You could do L'Hopital on this. You could do L'Hopital, but you have to do it 15 times. However, you can see easily. It's trickier to see here because you got the chain rule, the cube root of x to the 2/3. I don't have to worry about it. But if you look at this one, it's just e to the u now, and you can use L'Hopital on this. You know that the bottom is always going to stay e to the u, but the top, if you do L'Hopital enough times, what, 15 times? 15 times, the top is going to be a constant. And it's probably, what do you think, 15 times u to the 14th and 14 times 15? So it's, I'm thinking 15 factorial. I don't care exactly what it is. All I care is what the limit is. So it's 15 factorial, or a constant, over something that's increasing without bound. And so this limit is obviously going to be 0.